Hi guys, coming to you from my home office. If you could turn to page 78 in your books, we are going to just do some brief notes. No proofs will be included in here. So we'll just define a couple terms and do a few examples, and then you'll be able to work on your assignment. So the first thing we're going to do is show that the external angle of a triangle is equal to the sum of the two internal remote angles, called the exterior angle theorem. All right, so what is that? Basically, we're showing that if we take a triangle and extend one of its sides like so, then we're saying that this angle, which is the external angle, or you might hear it referred to as the exterior angle, that angle is equal to the sum of this angle and this angle. Those are the remote interior angles. Okay, so let's just quickly define external angle. The external angle is the angle formed by a side, let's just say by an extended side. The angle formed by an extended side and its adjacent side. All right, so that is that angle right there. And then the other two angles are the remote interior angles. So they're the two interior angles that are non-adjacent. Non-adjacent to the external angle. Okay, so we're saying that those two angles, when added, give us they are the same as the external angle. All right, so now if you could just flip the page to page 79, and let's look at these three examples. So example A here in the middle of your page. So we've got two interior angles, and when we add those together, we get 147 degrees, which is the same as our external angle, which is what we are asked to find the measure of. So measure of angle BCD is 147 degrees. All right, for example B, we're given the external angle and one of the interior remote angles. So we want to take our external angle and subtract the known angle to get the missing angle. And so that will be 44 degrees. Measure of angle B is 44 degrees. And measure of angle BCA, which is this angle right here, well, it's a linear pair. It forms a straight angle, or it's the third angle of a triangle. So either way, we can do 180 minus 65 for 115 degrees. All right, and I'm sure you can figure out measure of angle A and measure of angle BCA on example C. All right, so now let's look at one other theorem here. Still on page 79 here. Let's look at the mid-segment theorem. That states that the segment joining two midpoints of two sides of a triangle is parallel to the third side and half the length of the third side. So what does that mean? If I have some arbitrary triangle, all right, and I have the midpoint of one side, which of course gives me two congruent segments there, and the midpoint of a second side, which gives me two congruent segments there. When I connect those midpoints, we know that those lines, the mid segment and the third side, are parallel. Okay, we also know that this third side is twice that mid-segment. Okay, and going back to the fact that they're parallel, actually, that also gives us angles. Since they're parallel, we have some corresponding angles here, And that means these two angles are congruent as well as these two angles because they're parallel and they're corresponding angles. So let's practice a few examples. Again, no proofs for now. Let's just jump to let's skip 80 and 81, and we'll just go to 82 for these examples using the mid-segment, so you can then work on your assignment. All right, so I'm on page 82. Okay, so we're trying to find x and find y here. Well, x is the same as this segment, so x is going to be 8. And y is our mid-segment, which is half the third side, so that will be 9 centimeters. Okay, next example. X is the corresponding angle to that angle, so it is congruent, so 76 degrees. Y is the third side, so it is twice the mid-segment, so it will be 14 centimeters. All right, this next example, we gotta use a little intuition here, use some congruent triangles. So we have here two congruent triangles, okay? And I know they're congruent because I've got two sides and an angle. I know these two sides are congruent because, well, the mid-segment's half of the third side, and, well, this is half of that third side. And we obviously can see that those are congruent, and then we also have the corresponding angles. So these two triangles are congruent by side, angle, side. So, therefore, I know that y is congruent to that side, the 8 centimeters. So that's actually our y. And then x is that mid-segment, which is half the third side, so we get 9 centimeters. Okay, next example, x is the corresponding angle because they're parallel, so 86 degrees, and y is the mid-segment, so half the third side. Okay, this example, we have an isosceles triangle here. So I know that these two base angles are the same. So then we can find y, the vertex angle, which is going to be 180 minus 140, which is obviously 40. And then x is the third side, which is twice the mid-segment, so it is 16 centimeters. And this last example, let's find x first. X is twice that, so we're going to have 18 centimeters. Okay, and then we have to find y. Y is the entire side of this big triangle. So what we actually need to do is find the hypotenuse of the smaller triangle first, and we can do that.
What's that?
By using the Pythagorean theorem here. So we're going to do this small triangle. We know two of the sides, and it's a right triangle, which is why we're going to use the Pythagorean theorem. If we know two sides of a right triangle, we can find the third side, which is half of what we're trying to find. So we're going to do 12 squared plus 9 squared equals c squared. Take the square root to find that side, and we'll end up with 15 for that. Therefore, y will be 30. Okay, so that's a wrap on that. You can work on your homework packets. You should be working on GCO C10 worksheet 2, which is 2 pages, which deals with the external theorem, external angle theorem, and GCO C10 worksheet 3, which is 3 pages, which deals with this mid-segment theorem. So it's basically pages 3 through 7 in your homework packet. Please work on those, and I'll see you soon. Okay?